which is stationed out in the Atlantic Ocean. Now we're coming up on about T-minus 12 and a half minutes to liftoff. The launch vehicle and satellite teams are continuing towards an on-time liftoff scheduled for 1 a.m. Eastern Time. Falcon 9 team began their final checks at about T-minus 2 hours. Most recently, we completed the ground team poll to proceed with propellant load and launch that happened at T-minus 38 minutes. We began loading propellants at the T-minus 35-minute mark. Falcon 9 is a bipropellant vehicle. That means we have two propellants on board, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene that we call RP1, or rocket propellant 1. And to burn that fuel, we need an oxidizer. On Earth, most combustion or burning uses oxygen from the atmosphere as its oxidizer, and that oxygen makes up about 21% of the air that you and I breathe. However, in space, we don't have an atmosphere to provide that oxygen or other oxygen-bearing molecules, so rockets need to carry their own. On Falcon 9, the oxidizer is super chilled liquid oxygen, what we call densified LOX, and we chill it well below its boiling point, which increases its density and allows us to load more onto the first and second stage LOX tanks. Now, currently, we are fully loaded on fuel on the second stage. Fuel loading is underway on the first stage. That'll continue about until T-minus 6 minutes when it will complete, and liquid oxygen loading is loading on both the first and second stages and causing those plumes that you see around the vehicle. Now, once fully fueled, Falcon 9's first and second stage combine to carry over 1.1 million pounds of propellant, and we'll burn through most of that in the about 8.5 minutes that it takes to land the first stage and to get that second stage into its initial orbit. We'll also need an igniter to burn that fuel and oxidizer, and for that we use a chemical called TTEB, that stands for triethyl aluminum and triethyl borane. When it combines, it produces a characteristic green flash that we can sometimes see at the base of the vehicle, and that ignites our Merlin engines. Then those Merlin engines, the 9 at the bottom of the first stage, will begin throwing out their combustion exhaust out of nozzles at the bottom of the rocket, and that pushes the vehicle in the opposite direction. It's a great example of Newton's third law of motion. For every action, there's an equal and opposite reaction. Now, quick update on the weather. We started the day with a 10% probability of violating launch weather requirements. That is to say that we have a 90% chance of go. Been listening to the loops, and we aren't tracking any significant issues that would expect us to hold towards today's launch at 1 a.m. Eastern Time. The weather conditions also look good for booster landing on our drone ship and for fairing recovery out in the Atlantic. So with that, the launch vehicle, satellite, weather, and the range are looking good to go for that 1 a.m. Eastern Time liftoff from Launch Complex 39A. Now, as I mentioned earlier, today's IXPE mission is for our customer NASA, and it's the first NASA Launch Services Program mission being launched from Launch Pad 39A, but it also marks SpaceX's 5th as part of the NASA Launch Services Program missions. Those science missions include the Double Asteroid Redirect Test mission that we launched a few weeks ago, the Sentinel-6 Michael Freilich mission in 2020, the Transiting Exoplanet Survey Satellite launched in 2018, and JASON-3, which launched in 2016. But our payload tonight is a collaboration between NASA's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace. The Imaging X-ray Polarimetry Explorer will help us understand fundamental physics of some of the most energetic cosmic objects in the universe by studying the special properties of the X-rays that they emit. NASA's Tiffany Russell Lockett will give us a closer look at the main components of IXPE, where those X-rays come from, and how studying their polarization will help us better understand the universe in the years to come.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction,
Hello,
energy,
everyone.
and most importantly,
I'm gonna turn this down.
polarization. Over the 2 years of
Alrighty,
its
I
prime
hope you
mission,
can hear me.
IXPE will observe more than 50
I'm
brilliant
gonna
objects, like the
check
leftovers
just to
of
make
huge
sure.
stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once...
Okay, so you can hear or you can read the captions on the screen if you really want to hear what they're talking about. But yeah, this is IXPE mission, or the IXPE. It's going to a low Earth orbit. The booster will be landing on Just Read the Instructions drone ship. What else do you want to know? I'm going to try to open this telemetry thing. Give me 1 second. I sure hope it doesn't open on the second monitor. Oh, it did. No one saw that. Of course, now my computer crashed. Oh. Oh gosh. Okay. Let's try this now. That's better. Moist. Oh, if you were watching the SpaceX stream, you would have liked that. Oh, that was nice. One second. Okay, that's better. Now I think I can do this. Window capture. Oh, hey, look. Go for launch. Oh. Here we go, guys. 5, 4, 3, 2, 1, 0. Ignition and liftoff. Is that the moon right there? Oh. I couldn't see it that well, but I think it was. Oh, it died. Oh, it died.
To carry the second stage and the IXPE payload into orbit. So again,
I realized I didn't have desktop audio going in the background. That's okay.
And then SES-1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the atmospheric density drops off. So we get higher and higher in our atmosphere.
And coming up on Miko. Miko. Stage separation.
So those three events successful: main engine cutoff, stage separation. Left-hand side of your screen, you can see a view of the first stage deploying its grid fins, starting its recovery sequence. The second stage on the right-hand side of your screen, we've got a shot of the Merlin vacuum engine glowing as it continues its ignition to carry IXPE into orbit. Next major event coming up will be fairing deployment. At this point, the second stage...
Stage 2 on nominal trajectory.
The second stage is getting to a part of the...
You can see the lights in the first stage background. That's pretty cool.
And then attempt to recover them. Again, both of them being new fairing halves flying for this mission.
Fairing separation confirmed.
Fairing separation? Like how small that satellite is.
Of the fairing deploy, the IXPE satellite now getting directly exposed to the vacuum of space. And those fairing halves again will be attempting to recover those with our recovery vessel named Bob, which is
Bob.
out in the Atlantic Ocean.
I think the other vessel is Doug, which is Bob and Doug from Crew Demo 2. My first ever rocket launch that I watched.
So if you're just joining us, welcome. We're about T plus 4 minutes and 20 seconds into...
Whoa!
On your screen is a view of the Merlin vacuum engine on the second stage.
69,420.
Its first of two planned burns to take the IXPE satellite into an
Funny
initial
number.
working orbit. We had an on-time liftoff at 1 a.m. Eastern Time. The first stage that...
Sup, Nintendo, bro?
This far, separated and is on its way back to planet Earth. Its next major activity will happen at about T plus 6 minutes and 20 seconds. And that'll be for the entry burn, where it'll ignite a few of its engines to slow down in preparation for entering the Earth's atmosphere. Now, during the entry burn, we'll relight 3 of the Merlin 1D engines on the first stage. That'll start with the center engine, followed shortly after by 2 of the side engines. That'll slow down the vehicle as we pass back into Earth's atmosphere. And we need to slow down on the first stage to reduce the entry forces, which helps us recover and reuse that first stage. Reusability is a key part
Stage 2 on nominal trajectory.
of lowering the cost of space flight, which enables more investment into the critical scientific hardware and research. Now, Falcon 9's first stage that supports
Where's
today's mission will perform
landing?
its entry burn for the 5th time, having previously done so for the Crew 1,
I could be wrong, but it's not on that timeline.
M8 and CRS-23.
It just says entry.
And those brand new fairing
Oh
halves
boy.
will also re-enter Earth's atmosphere for the first time. The second stage continuing to burn. Its burn will continue until about T plus 8 minutes. And we've heard periodic call-outs that we are seeing nominal performance and following a nominal trajectory.
Stage 1 MTS is safe.
On the second stage.
And nitro. Never mind.
So
You could see the
left-hand side of your
nitrogen
screen, you can see the grid fins and you can
things
see the plume.
firing. That was pretty cool.
Entry burn. At this point, we are firing 3 of the Merlin 1D
Yes, hee hee, funny number. I know.
and we're
Funny.
decelerating the first stage, but we're still going pretty fast. So as we're flying into the Earth's atmosphere, that soot is actually
You can
getting
see that
kicked back-
speed.
Excuse me, the plume is getting kicked back
Entry burn, shut down.
onto
That
the first
speed
stage.
was going down.
And the plume is carbon-based, so that'll deposit a nice layer of soot on the first stage's surface.
Stage 2 on nominal trajectory.
Nominal shutdown of the entry burn. The next activity for the first stage will be the landing burn. That'll happen at about T plus 8 minutes. And 10
Oh,
seconds.
stage 1 telemetry cut out.
Continuing to look nominal. Now, the
Oh, it's
engines
back.
on both the first and second stage are different. The Merlin engines
Also,
on the first
That's the landing right there on the timeline.
But the Merlin vacuum engine that you see on your screen is optimized for vacuum. And the difference there is how much we can expand the
Stage 2
pressurized
FPS is saved.
gases that are being produced by the Merlin
Stage 1
engine.
transonic.
Call out there for stage 1 being transonic, so it's transitioning from supersonic speeds back to subsonic speed. And next events coming up will be
5 kilometers on stage 1.
Shutdown of this Merlin vacuum engine, and pretty close after we'll hear a call out for landing burn startup on the first stage.
2 kilometers on stage 1. Seco on stage 2.
And back engine cutoff.
So shutdown of the Merlin vacuum engine. We've got landing burn startup on the first stage.
Oh boy.
Left-hand side of your screen is a shot from the drone ship.
Yep, that's a shot from the drone ship. You can't see anything.
Landing leg deployed.
And correction, that's a shot from the first stage. And on the right-hand side is a shot from the drone ship. We've deployed the landing legs, hopefully for a soft touchdown on
Nice fuse we got there.
Stage 1 landing in progress.
Nice, nice, nice.
And that is a 97th successful recovery of a first stage on our drone ship named Just Read the Instructions. This particular first stage having scored 5 flights under its belt.
55. No, that was just 5.
Second stage on your screen is now embarking on its first coast phase, and it's in its nominal orbit.
Alrighty, guys. That will be the last of my stream for the IXPE. That was actually a pretty solid stream. It didn't really cut out at all, so I think I will keep doing these streams. Thank you all for joining, and I'll see you all in the next stream.